Hey everyone, Nick Dearbertis here teaching you financial modeling. And today we're going to do an introduction to Pandas. And this is part of our lecture series on understanding complex results using visualization. So we want to get to be able to visualize our results in Python, but there's a little bit more that we've got to learn before we can get there. So in Python, we talked about how there's lots of different options for how we can visualize the data, but we're going to focus on using Pandas, which uses matplotlib under the hood to do our visualizations. So we've got to go and learn about how to use Pandas in the first place, because it does a lot more than just plotting and tables. But we got to learn Pandas basics, and the basics really revolve around the Pandas DataFrame. So the DataFrame is this new type of object that we haven't worked with before. You know, we've worked with lists, numbers, strings, all the basic kinds of data types, but I've mentioned how anyone can create their own data type by writing a class. And lots of third-party packages out there create these custom classes for you to use, which give all sorts of functionality. So that has been done in the Pandas library. They've created the DataFrame class, and so that defines this DataFrame type that we can use. And when you think of a DataFrame, think of basically a table. So, you know, with lists, numbers, all the dictionaries, all the data types we've thought about so far in Python, nothing really is like a table. But we have these data frames that can fulfill that role for us. So before we even get into the graphing side, we've got to learn about how to work with data frames with these tabular representations of the data. And there's quite a lot that we can do there. And it will really become a basic tool in your toolkit for solving problems in Python. A lot of people use data frames as a very fundamental building block in their models as a way of storing and working with data. So what we're learning here has a lot of applications beyond even just the visualization. So what is this data frame thing that we're about to learn about? Again, essentially you can just think of it as a table. It has rows, it has columns, but there's a lot that we can do with them. So some of the features that data frames have, you can, even after it's created, you can add or remove rows and columns. You can aggregate that data in a lot of different ways with summary statistics and grouping by different things. You can go to and from different data formats like Excel files. You can read in Excel files, export to Excel files, as well as working with databases and lots of other output formats. You can take multiple different data sets and you can put them together by joining and merging and concatenating. You can resample and reshape your data, thinking about, different frequencies. You have monthly data, you want to take it to annual data, or other ways of reformatting your data. You can slice and dice and query from your data in any sorts of ways. Maybe you have data on countries and you just want to get the data for the US. Well, you can just query for that US data. And you can deal with different patterns in your data, such as duplicates. You can remove those duplicates. You can remove missing values. You can fill in missing values. Lots of different things you can do to manipulate the data which you have in your data frames. So this is why I mentioned that this is really a fundamental building block for most people as they build out their models, because there's so much that you can do with it. And this is really the gold standard library for working with tabular data in Python. It's very, very popular. It's used all across finance and the data science industries. So most people who work in Python are at least familiar with Pandas, and a lot of them use it on a daily basis. I definitely do. So what does this data frame basically look like? How do we create one? How do we work with it? So here's a very simple example of how you can create a data frame. We'll talk about a few different ways that we're going to create data frames in this course, but here's what I think is the easiest way to get started with one is, of course, this is a third-party package that we're using, so we do have to import that. So we're going to import Pandas, and the convention that everybody uses, if you Google anything about Pandas, you're going to see people using the same convention, is to import Pandas as PD, and then you always do PD dot whatever you want to use from Pandas. So to create this data frame, it's going to be pd.dataframe, and we're going to assign that to a df variable so that we can use that going forward. Now, I had everyone install Python with Anaconda in this class, and so Pandas is already installed within Anaconda, so you don't have to go and install that. But if you did not use Anaconda, you have some other Python distribution that does not have Pandas included, then you will have to go and install that package before you can use it. But as long as you installed Anaconda, it should be there already for you. So we have this data frame, and right now it's an empty data frame. We didn't give it any data to start with. So that's where we are as of here, an empty data frame, no data in it. So then what we can do is we can add some columns to this data frame. So we're going to add a sales column with these values, and we're going to add a category column with these values. And then when we look at the data frame, we'll see something like this, a tabular representation of the data, where we have sales and category as our columns, and then we have the rows of this data that we passed in. So that's a basic way of creating a data frame. First, you make an empty data frame, then you assign the columns one by one. And we'll look at two other ways that we generally make data frames, being that you can create it all at once with the data all within a single command. And the other main way is to load from some kind of external source, like reading in an Excel file to create your data frame. So then let's jump over to the Jupyter Notebook example on how we can work with these data frames. So we're over here on the intro to Pandas and visualization notebook. And so first thing that we're going to do, as always, is we're going to import what we need. So we're going to import Pandas as PD so that we can use that throughout. And so the first way that we're talking about creating a data frame, we create it first, assign columns later. So here you make the empty data frame, and if you look at the empty data frame, you basically see nothing because there's no data in there. Then we can go and we can assign a column to it. So this is going to be assigning the name column, and it's giving the values Joe, Jim, and Mary. So then when we run that, then we see this table representation with the column name, and the values Joe, Jim, and Mary. And the reason that we use brackets here, whereas before we've just looked at brackets being able to look up something in a dictionary or look up something in a list. Classes in Python define that the way you work with objects, and the way that Pandas has defined their data frame class is why you work with it in this way. So it's all in the particulars of the implementation of the class. So in order to get something useful in this data, let's assign a few more columns. So for each of these people, now we have a weight, we have a price that they're willing to pay for some good, the reservation price, and we have a percentage of the time that they spend doing activity, like outdoor activity or something like that. So now we can see all of that laid out in a table in a nice clean way. So the other main way to create a data frame is give it all the data at once, give it all the columns at once, and it's definitely a little more complicated syntax to do that, but it can be useful in some cases. So here we're passing to the data frame a list of tuples. So here's the outer list, and then each item in the list is itself a tuple. And each of those tuples has the data for a single row in the data frame. So here's all of Joe's values, here's all of Jim's values, here's all of Mary's values. And then after this first argument of the list of tuples of the data, then it's a comma, and then we can say columns equals, and we can give it a list of the names of the columns for the data frame. So those columns come directly to be the names of the columns. And so doing this, we can create the same data frame that we made above by assigning the columns individually, just all at once in a single command. So now we have this data frame, which has a few different people and some characteristics of those people. How do we, now just saying we have that data frame ready, how do we pull out what we want from that data frame? So similar to a dictionary, we can put the name of the column as a string into the brackets, and that will pull that column out of the dictionary. So this reservation price, each of these values have now come out when we access the reservation price. And what we have here is actually a series. A series is the other main class within Pandas, and it represents a single row or a single column of a data frame. So that's how we get one column. You can also select multiple columns at a time by passing it the list of the columns that you want. So do notice that we have the double brackets here because the outer bracket means I want to look something up in the data frame, and then the inner bracket means I want to look up this list of columns. So if you omit that brackets, the inner brackets, then it's not going to work appropriately. You're going to get a key error because it's trying to now look up a single column with a name of this whole thing, which doesn't exist. You do need to have that second set of brackets so that it's saying, I want to look up a list of columns and give me each of those columns individually. So that's selecting columns. Now how do we select rows? So there's this iloc we can do on the data frame. That's integer location. So that's just saying 0 would be saying give me the first row. Once again, 0-based indexing, as with nearly everything in Python. So 0 is give me the first row. So we can see, again, this is another series that we're getting because any individual row or column of data frame is a series, and that's why it displays a little bit differently. But we can see we have all of Joe's values. Joe had the 150 weight, and that's what we're indeed getting here. So, and if we went to 1, then that would be getting Jim's values, and 2 gets Mary values. And if we try to go above that, we would get an index error because there are not that many rows in the data frame. And that's where you get this single position indexer is out of bounds. You should see index error out of bounds. You should know that you're trying to go further than exists in the data frame. We can also pull out something by both rows and columns, so that we can do with loc. So loc, you can give it 2 arguments in contrast to the iloc. And so with loc, we tell it first what row we want to look up and then what column we want to look up. So we're going to look up the first row, and we're going to look up the reservation price column. So here's the data frame again, just for reference. So we want to go to the first row here, and we want to look up the reservation price column. So that's why we get the single value of 10.12. And then we can also query for whatever rows or columns of the data frame that we want. So here we're going to get any rows which have a reservation price which is less than 14. So we can see the row, the gym row, which had a 15 reservation price, is no longer here in this query result of the data frame. But we do have the other rows because their reservation price was less than 14. So you can kind of read this syntax as give me the data frame where the data frame's reservation price is less than 14. So you do have to like repeat this data frame variable. You can't just do something like that. It's not going to understand that. It does have to be look up the data frame where the data frame's reservation price is less than 14, and then it can work. So we can do multiple queries at once as well. You just have to separate them with an ampersand and put parentheses around each one of your queries. So here we're doing what we did before and getting the reservation prices which are less than 14, but we're also going to get only those rows which have the percentage active greater than 60%. So Joe had 60%, that's not greater than 60%, and so that's why when we run this, we're left only with the Mary row. That's the only one that satisfies all of the conditions that we've given to it. But it's very important to include the parentheses. If you omit any of those, then it's not going to work appropriately. You don't need them in this special case of just doing a single query. They don't hurt, but you don't need them. Whereas with multiple queries, you definitely do need them. And then we can pass these same kind of queries into the loc command as well. And for that, we do the same kind of syntax for the row part of the loc, and then we can also pass it whatever columns that we want to get. So we can take this same exact query that we had here to get this Mary row, and that comes as the first argument in loc. And then the second argument is what columns we want to get. So here we're getting just the name and the weight columns, and that's why we see just Mary's name and weight. And you also could give it just a single column as well, and that is going to just give you that value. So that's selecting things out of data frames. Let's look at some basic math we can do. So you can take an entire column at once from a data frame and do math with it, which definitely simplifies things, whereas before we would have always had to create loops to be able to apply these operations across all the different values of our data. Here, it's one simple expression in Pandas. So we can just add 10 to the reservation price column, and we get a new column which has 10 added to each of the values. We can also do math with multiple different columns of the data frame. We could multiply this price by the percentage active and get the result of that here. And we can, any data frame which has just numbers, we can do math with that as well. So here, taking the reservation price and weight columns out of the data frame, we can multiply those both by 10 all at once. And you can also take the result of these things and assign them back into the data frame as new columns if you would like. And we can also do some summary statistics very easily with data frames. So .describe kind of gives you the overview of all the different summary statistics. You get how many there are of each, you get the average, standard deviation, minimum, different percentiles, or you can do each of these things individually. So, .mean to get the averages, .std to get the standard deviations, .quantile to get, here would be the 50th percentile, which is the median, and you can do whatever percentile that you want in this. Min to get the minimum, max to get the maximum, and any of these operations you can apply it across the row instead of the column if you would like. And so this is taking an average of all the numerical values in a given row. And so this is saying this is the average of Joe's values, this is the average of Jim's values, and so on. And so you just pass this axis equals 1 argument to one of these summary functions to be able to do that. And axis equals 1 just means work over the rows instead of working over the columns. And then, these are all the kind of the built-in things, but Pandas also has a way that you can apply any function you want across a DataFrame's values. So here's another application where creating functions for all our different logical steps becomes very useful, because then we can take this function we created and apply it to every single cell in the DataFrame. And so here, this is a simple function that just takes the value and multiplies it by 100 and returns the result. And it's this apply map that is able to take a function and apply it to each individual cell in the DataFrame and return a new DataFrame which has the result of all those calculations. So we run that, and we can see we get 100 times each of the values that were there before. And even for the strings, we get those repeated 100 times. So it was able to take this and apply it to all the different cells in the DataFrame. Now, one thing that you'll notice is there's no open close parenthesis and passing some kind of number or arguments that you would expect to normally see with a function. And that's because when we do that, we're calling the function, right? So we pass it a 5 and we get 500. And now the result of this is just that 500. This function has been called, it's been evaluated, it's gone. Now we're just left with 500. When we don't do the parentheses, that's the function, a reference to the function itself. So that's why we see, what is this thing? It's a function. It's the function multiplied by 100. And so with this structure, we're passing the function itself into this other function, apply map, so that apply map can take this and apply it to each of the cells. We have to pass the function itself and not the result of calling that function. So this definitely is a concept that a lot of people struggle with in the beginning, but we want to pass the function itself, and so we don't put the parentheses, whereas essentially every other use case of functions, you do want to call it and get the result of that, and so you use the parentheses and pass whatever arguments. So that's a quick overview on Pandas and DataFrames, and we're going to come back next time to look at some ways that we can style our DataFrames to make them look better. So thanks for listening, and see you next time.